Alright, today we're going to be going over the smart power stages, which are here on the Z15. We're also going to be covering these power stage controllers right here. Now on the Z15 boards, the version 2, they use the Antminer controllers, where the version 1 uses the Renesas, however you pronounce that. So let's dive in. So each controller controls these 6 power stages. I call them MOSFETs just to make it easier and everybody understands what they are, but they're smart power stages. Now these Infinite controllers right here, they are programmable, meaning you have to have the programmer to replace these, because if you just swap a new one in, it's not programmed, it won't know what to do, and maybe it'll do something funky, I don't know, but it won't work. So how do you connect to these controllers? Alright, right down here in the corner you have a connector, and this is where you connect your adapter. Now it uses the PM bus adapter. So Infineon has their own, Renesas has their own. So this layout here will be different for different boards depending on what controllers you have. So this connector here connects directly to these controllers here. Let me pull up the board. So this is actually a version 1 on the Zeus mining site. It's the only repair manual available. So it kind of shows you though. Here's the connector, and it connects directly to the chips here. And then also here's where it would go to the PIC chips here. When we connect to the smart controller here, you have to have the right programmer. You also have to have the right adapter. So it's pretty complicated. So don't ask me where to get the software, what to buy, because I really can't say much on that. You just have to find that out for yourselves. Because the company that supplies the software is not very friendly. Let's just say that. So anyways, yeah, so the connector connects directly to these controllers here. And then these controllers connect directly to these MOSFETs or smart power stages, and they turn them on individually. They also have a temperature sensor. They have a amperage sensor, all that. So they communicate directly to the controller here. So I'm going to give you an example of that, where this controller here was not turning on because it should be having 7.78 volts here coming out of here, but this wasn't turning on at all. So I actually haven't seen, well, that's not true, I've seen one bad controller, but usually the controllers don't go bad. So when they don't turn on, that usually means there's an error here. So what you do is you plug your adapter in here to the thing, power on the board, and then you can go in, and each of these controllers are on their own address. So this one here would be 50, address 50. This one here would be 54, and this one here would be 58. So this is address 58, 54, and 50. Now this really only matters on the Renesas controllers for the bus address, but anyways, it's just helpful to note. So anyways, on this example, this controller here was not turning on. They're supposed to be 0.78 volts, at nothing. So I went ahead and I will plug it in and plug the adapter in, and I will show you an example right now.
Alright, we have a Z15 here with a problem. It's missing voltage on this rail here. These two turn on, not this one. So what we're going to do here in this video is we are going to plug this into the computer so we can read the chips, the controller chips right here. We're going to go ahead and read it and see what faults it says. So let's go ahead and do that. We got our connector here. Plugs in right here. Now black is ground. So you're going to plug it in. Focus, 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 focus. There we go. It's hooked to the USB adapter to the computer. Alright, let's fire it up and see what it says.
Now here you can see there's an error. Red dot means error. It's producing no amperage or voltage. You can see right here. I'm gonna hit the telemetry, and as you can see, keeps going back and forth here. As you can see here, it says driver is not ready. So that tells us there is a problem in one of the driver MOSFETs. Basically, it's a PWM error. So the communication between one of the MOSFETs and the controller is not working. So I'm going to go ahead and do some testing on the PWM signals and see what MOSFET's not working. And go ahead and replace that MOSFET or reseed it, whatever it needs. And I'll be back. So got it replaced. Everything looks good. Chip's powering up. You can see a 0.78 volts there. They're all drawing about 13-16 amps, and the temperature looks good. Alright, you can see everything looks good, no faults or anything. You can see each individual MOSFET pulling about the same amperage. So everything looks good here. So I'm going to go ahead and give you an example of a running board that's actually hashing, and we can take a look at the power draw and monitor it. Alright, so here we go. We're fully up and mining, drawing about 150 amps per ASIC. As you can see here, temperatures look great on these power stages. And you can do all kinds of stuff with this software. You can do temperatures, you can read all the faults, you can adjust power settings, amperage limits, overprotection, all kinds of stuff. So we can pull up the telemetry here, and you can see each MOSFET here. Each are pulling about 24-25 amps. All looks pretty consistent, good temperatures. So yeah, that's about it for this. Go ahead and hit that like and subscribe, because this took some time to do and a lot of research. So hopefully I earned that much, and I will see you next time.